Right, hello. Firstly, I'm filming this in 360 degrees, so if anyone objects to having their face up on the internet, please let me know and I'll blur you out. The reason for this is one of the bits of kit that we're starting to see being used more in the construction sector now. Being capable of filming in full 360 degrees allows us to put it onto people's devices, whether that's an iPad, a mobile phone, so they can go out and experience a construction site. Say if there's a problem out on site, you can actually put the camera beside it, explain what the problem is, and we can then use this also for training and teaching. I'm going to go down here. Unfortunately, I haven't got enough free USB ports on my laptop for have a clicker, but I will hopefully be able to engage from down here. So, my name is Dr. Maxwell Mallia-Parfitt. I come from Fulcro, studied at the University of Reading, did my Masters, my PhD there. Slightly different sector, still with an engineering theme, so I was robotics, space robotics. I also taught virtual reality for 5 years at the university to undergraduates, and saw a need in the construction sector, so moved across. Joined Fulcro, and this allowed me to then develop the technology that you're going to be able to see today, and we're putting this technology now into the hands of construction workers, but also students, to really train them up on what's coming and how we're moving forwards. So, quick overview of today. We're going to have a look at the history of visualization very quickly, and then looking more in detail at virtual reality and augmented reality. These are terms you're probably hearing more regularly now. We'll also then have a look at the future of construction, how these things are going to make changes going on, and then at the end, a bit of fun. We'll do a bit of audience participation, get people to come down and have a play with some of the kit. So, what is visualization? Going back to ancient times, could be something as simple as a cave painting, a stick drawing. It's some way of representing the physical world so that other people can understand it. So you've got Leonardo da Vinci there with his very, very technical, accurate drawings, which even today people are able to rebuild his machinery from his drawings. So it's ways of conveying information. So, how are we doing this in the modern age? Well, we've got BIM, we've got CAD. These are accurate ways of drawing and representing information, but far too often, what you're getting out is a 2D format. And if you've ever given a plan to someone in 2D form, first thing they normally do is turn it around in their hands and try and work out which way's up. So, virtual reality allows us to then step inside those drawings and understand them in a more immersive and understandable way. We can do this with head-mounted displays, with, PowerPoint presentations like this is a form of visualization, but we can then also interact with virtual reality, and that's the key. It's the interacting with the data that's lying underneath and be able to interrogate it. So a couple of simple examples of VR simulations, from very high level, how are we going to lay out a neighbourhood, to then being able to actually stand on the sidewalk and say, right, what is this development going to look like from the ground? There is technology out there, such as cave technology, which actually allows you to stand physically at a one-to-one scale inside your model. So if you have a model of this room or a laser scan of this room, we can recreate that anywhere where we have one of these bits of kit, and you can stand in it and experience it as if you were there. Moving on, you've probably heard of Oculus Rift. It's making headlines all the time. The fastest crowdsourced funded project. I think it was 20 million raised in 48 hours. It's now hit the commercial mainstream. You can go out, you can buy the device. I've got one of them here so you can have a play. But then moving further on, making it more accessible and putting it into the hands. Your mobile phone, has anyone got an iPhone 4 or above? Or equivalent Android device? Hopefully it'll be 90% or more of you. In your pocket, you have more processing power than the entirety of the Apollo moon landing mission. In your pocket. Now where we're getting to is being able to actually take mobile phones, and rather than having to have dedicated hardware, is put your mobile phone into a piece of cardboard like this with two lenses, and you've got virtual reality on your phone. So again, these are things that we can then put into students' hands, into the next generation, and they're already used to this technology, so the construction sector here, we're trying to keep up with what people are expecting. And this leads on to immersion. Now, the idea of immersion is to put yourself physically somewhere else and make yourself feel like you're there, whether that's from 3D visuals, 360-degree stereoscopic sound, or even touch and feel, so haptics. People are experimenting with smell and taste. If you've ever been to the London Dungeon or one of these theme parks, sometimes you get whiffs of things that are meant to put you into another place. So the whole idea of immersion is to put you into another environment. However, immersion can have its drawbacks. It can cause what we call simulator sickness, and some people do find they get motion sick. So there are drawbacks to all kinds of technology, but there are ways around them. Now, virtual reality in construction, to name a couple of headlines here, Crossrail, largest infrastructure project in the Western Hemisphere, £14.8 billion worth, linking east and west of London with 42 kilometres of new dual-bore tunnels, using virtual reality to do design reviews, health and safety inspections, model checking. National Rail are using VR to train drivers on new high-speed rail routes, being able to pick out things like where's the best position for a signal so that we can see it uninterrupted. The Queen Elizabeth Park for the Olympics used VR to basically look, how is this site going to work? Are we going to have enough flow for crowds to move through? The Heathrow Terminal 5, again, modelling of passenger flow inside the terminal. Different application areas, so you've got your design reviews, being able to get teams all over the world to work together on the same model and understand a problem. Using it for training of personnel, so we can take something like a 360-degree camera out, put it beside a high-speed railway, 120-mile-an-hour train coming past, and we can do that with someone who's already site-trained, safe, working, be able to then replay this in a safe environment, say at college, and scare the hell out of new students. But it shocks them to the core, and that's what we're trying to instill, is the fact that there is, whilst there might be idyllic setting, there is a very dangerous environment right next to you. So other things we can use, site planning, looking at the use of 4D data. So this is going from the third dimension to then looking at time. And we saw that brilliant video earlier of the college stacking up over time. This is where we're able to start scheduling and looking at how things are going to work when we actually get out to site. And then also client engagement, very useful, and we'll see some pictures later on of that. This then steps from virtual, which is completely artificially generated, to augmented, which takes the virtual reality and overlays it onto the real world. And we've got a couple of demos here today, so you'll be able to play this as well. The idea here is, whilst we've got data that's already geo-referenced, we can take information, so here we have a 2D plan, you aim an iPad at it, and out pops a 3D model. Makes it a lot easier for people to understand. Some people really can't understand a 2D plan and how it's a section through a building. So a lot of people who are in the industry 30 plus years, it's second nature, no problems, you can read a 2D plan and know where you are. But for someone who's used to 3D technology, you put a 2D drawing in front of them, it's very difficult. We can also use it for looking at changes or proposed changes to a building. So here you see on the floor, there's a big code. With an iPad pointing at it, they're then able to look at different stairway designs and revisions. Another potential use, groundbreaking ceremonies. Far too often it's someone shoving a spade in the ground and that's all you see. By putting a code out on site, anyone with an iPad can then see the proposed building in situ on the site. Unfortunately, we came a bit too late to the Dudley College project, otherwise we would have had that out there. But you're going to start seeing this more and more in this sector. So where has augmented reality been used so far? The Reading Station development, they used AR to visualise the new canopies over the platforms. Bentley Systems is using it as a potential way of helping blind people navigate through underground stations. Also showing workers where to put temporary works so that you're not going to have trip hazards, you're not going to block access routes. Bond Street Station, they've been able to, because of the amount of work they've been doing down there, they're now able to show you what it looked like 10 years in the past and being able to then show over time how things have changed. But also in user engagement, being able to put that technology into the hands of a client and get them to see things, or where we've been talking to Dudley College, you hold an iPad up at the wall, you'll be able to see what pipe work, what structural elements are already in that wall, and really useful as a training tool. But you've probably also heard the term big data. One of the problems with all of this information is there's so much information. Modern construction sets can go from anywhere from 60 megabytes up to 6 gigabytes for a building. And these are huge. Your mobile phone probably tops out 32 gig, maybe 64 gig if you're lucky. But laser scans these days, you can go out on site and you can generate a hell of a lot of information very quickly. Looking at the future of Crossrail, they're predicting per day they're going to produce 100 terabytes of data. That's 64 gigabytes a minute. That's more than your mobile phone will be able to hold every minute of data. That's a hell of a lot. So how do we effectively interact and visualize this information? Well, this is where the rise of gaming technology is really beginning to help us. Gaming technology, great. You think, oh, I can just drive around in a car, I can walk through a building and shoot zombies. Well, what this gives us is, whilst CAD is very, very accurate, gaming technology doesn't really care about whether something is millimetre accurate. And for a visualisation, millimetre accuracy isn't required. So gaming technology is capable of running a lot faster. Far too often you try and rotate a model and you have to wait for components to update. In gaming technology, as you'll see today, you're able to walk through at real life speeds. There's also a hell of a lot of developers out there, so we're being able to draw on skill sets in other markets to come and help us develop the technology to really drive this sector forwards. Now, I'm going to put you back 3 years with the technology. I developed, under an EPSRC grant, the 3D Move, and this is technology that Crossrail's been using for the last 18 months, and actually testing and seeing how virtual reality can be used. So I mentioned before a cave. Normally these are purpose, custom installed rooms, normally 700 to £1 million, so £700,000 upwards. Very expensive, very difficult to use. Crossrail said, well, it's all fine and well for us to come out to Reading, but we're taking senior management out of the office, bring them to Reading, and we're wasting a day. What can we do to bring this on site? So I developed the 3D Move. This is just a time-lapse video. You can see we've just unloaded it from the van. This is the first time these two chaps had ever seen it or put it up. This was only the second time I'd put it up. It was very lightweight, made from carbon fibre and fabric screens. Gives us the ability to put it up just like you'd put up a tent. But the difference here between £1 million installation, this thing here, not including my time, cost £20,000. So the technology has come massively down in price, but gives identical experiences. So it's really moving forwards now. So you can see we've put the screens up, we've got some integrated 3D printed tensioners so we can tension screens. We then aim some projectors at the screens, do a bit of calibration, doesn't take very long at all, so you can see there we're 28 minutes in, we've already made it into Windows, do the calibration, at which point we're up and running, and there we are into a full 3D model of, in this case, Whitechapel Station, part of Crossrail development. And this environment, you can have 5 or 6 people quite happily standing there. And the benefit of an environment like this over a head-mounted display is it's collaborative. You can have 5 or 6 people in there discussing, you point at something, everyone knows what you're pointing at. It's there at life size as well, so you're not having to judge distances, you can see them physically. And it's a very useful bit of kit. Now the problem with this was it was very large, again took up quite a sizable amount of space, and we'll see the later revisions in a second or two. That's actually my wife approving the scale. It's her touching in an Oyster card barrier. And we've also demonstrated this to Crossrail. You can see they're wearing funky 3D glasses, allows them to actually get depth perception to judge distance. But actually using it in anger, out on the Crossrail project, we've actually had them doing design reviews and looking at very complex models up to 14 million polygons. Since then, we've smashed that record. We're now up over 100 million polygons, so we're able to look at large infrastructure projects, including all the MEP that you'd see in the roof. So this brings me on to the Fullmax. The Fullmax, again, is a virtual reality environment, and it projects onto 3 walls and the ceiling, which allows us to then play back 360-degree videos. Virtual reality tours, buildings. We have Dudley College Advanced 2, which we're working on in here as well, and you're able to explore the entire building. Again, showing the ability to point, or in this case, do hand puppets, but able to really talk over a design very quickly as a group. So, Before we go on to the live technology demo, I'm just going to do a quick cable change. Who here has used a 3D scanner or seen a 3D scanner in use? A couple of you. So what we have here is a handheld 3D scanner, and this is great. It cost £2,000. We're not worried about students dinking it. It will go out on site. It's waterproof. But what you see here is the auditorium in the room, and I just did this very quick scan in 3-4 minutes, just wandering around in this area. But the great thing here is we can start going in and taking measurements. So if we wanted to know how deep the desk was, we go from one end to the other. We can see the desk there is stating 80 centimetres. I might have missed, there you go, I missed it, that's why. So let's try a different angle. But it's very quick, very easy to use technology. So there we can see the desk is, technology never works. I've got fat fingers and I'm trying to drive it. But you get the idea. It's very quick, very easy to use. I will leave this out on the table. I'd like people to come play with it. Let me just switch back to the other computer. So, technology demos. Volunteers, please. Anyone wanting to come and try some VR? It's got to be one. Perfect. Right. Why hasn't the projector come back? Any ideas? No. Well, it's going to have to let me down at some point. So what we have here is one of the Oculus Rifts. I'm just going to start the software. So if you want to that on your face the camera, you should be able to wear your glasses with it. So So this visualization here, we've talked about modular earlier today. This is one of the modular plant rooms that we've developed, and with the Xbox controller, so I'll give you this as well. Here's your controller. Using your thumbs on those sticks, you should be able to navigate. So wherever you look, and if you turn your head, you're able to look up and down as well. So we can see what he's seeing on the screen here, but the difference here is he's got two screens, one for each eye, which is then giving him depth perception as well. So he's able to then get inside the buildings. So if you want to drive forwards towards, so with your right thumb, you're then able to get inside the pipework. And we can start then simulating real-world systems. So if we've got valves in there, by actuating the valve in the virtual reality, if we've got a motorised valve out on site, we can actually get it to control it. The boilers here, we know that we've got an API which allows us to get in and control them. We're able to then also record systems, so we can, on purpose, put a real-life system into an error state, and then by actuating the valves here, you're able to then go and resolve the problems that we've caused. So the technology, it's all about immersion. It's all about getting you in there and making you feel like you're actually in the environment. Now, one of the most powerful bits here, if I just stop you moving with your hand, if you want to take a step to your left, you can see you're actually able to physically move in the environment as well. So if you want to look under the pipe, if you just duck down, there we go. So this is the immersion. This is getting you into the environment and actually feeling it. So I'm going to leave these running. Please do come play with them. I also have an iPad, so I was talking about the fact that it's difficult for people to understand 2D drawing. What I've got here is a 2D plan. Hopefully everyone's seen one of these before. And by pointing the iPad at this plan, it picks up the plan, and then you get a 3D building chopping on top. By tapping the screen, you can isolate parts of the building with dimensions. So please do come play with the kit, and I'll take questions whilst people are playing. Thank you.
I first saw that at Wolverhampton years.
Okay, folks, by all means, come down and have a play with the kids. If you want to escape at any point, then we would appreciate the feedback on the feedback forms before you disappear. Just leave them at the front before you go.
Just have a look around.
You had nothing like that.
I'm quite used to that.
You all that?
It is, isn't it?
It is what? Getting the kid.
Is that the box?
That's Paul Jones, he does everything fast.
You can look around.
I'm going to see virus on this. Which scares us? I'll let
You can do your own review.
Yeah, I know, yeah. I could. 360 degree on this one.
She gone weird. Tell you what. It scares us. What's she scanning in? I don't know. Neil. Hold on. Where's your old? Oh, go in. Have a good plan down there. Again, you can do that for you. I bet you know. Sorry, one again. Oh, well. You're going back in the Oh, I can't handle that. Jesus Christ. Oh, that is good to get out. If you get too quick though, it sends you funny, doesn't it? Mark, it's a mess anyway. It's good to time. So don't nearly kill that. Dave is ducking into his 360 scanner.
Nice shot at the back of my head.
It is, but when are we ever going to get it? Oh yeah, what is about? Could have a telescopic with batteries in it. A robot with a paddling trowel.
We can give you some tablets for us. Just more tablets.
I've got one.
It's amazing. They're brilliant. I've got the one that was downstairs. It's got controls on.
You're gonna have a go with the headset.
You're going to have a go at it?
I'm not, I'm gonna
So you thinking, oh, one there, one there. You stick all the angles up and then you hang everything on it with the yeah. Not for that one. Because you download it.
That's what I mean, you download it.
You found in there, you hold it in with the elastic band. You can in schools and you say to all the kids, get your phones out, now download this app, there you are. How bloody fantastic is that? Imagine all these kids. These are £1 each. These are £1 each.
Have we got some already?
The bit that where it builds itself is on the intranet. If you look under Learning Quarter, Advanced Tutoring, it's already on the intranet.
Yeah, that's
If you guys field any questions, they might have as well. Okay, no problem. They always, even people that say they were going to come and have a concert, that always happens. This is good. Big building, isn't it? Those things over there, it feels like it's in there. Playing games,
the game gear, boxes, What you can do that?
When you look at that, you see all the pictures. It's not like it's not clear. It's just all picture. See it, it's 7 pixels. See it, it's not clear. Everything we can before, is it?